name is Dennis Benila. Welcome to today's video. Today's video is actually a follow-up of the last video I posted on components of a solar PV system. So today we'll be diving into solar panels and batteries. And yes, I'll be having my colleague David Udosen join me as we give a wrong view of it, and it promises to be very insightful. Alright, let's get started. So for solar panels, the solar panel is made up of a photovoltaic cell. The photovoltaic cell converts sunlight into electricity. Now a PV cell consists of semiconductor materials, and suffice to note that silicon is the most used semiconductor material in the world today. Now losses may occur from a PV cell as a result of ohmic resistance, reflection, recombination, and photons not having enough energy or having too much energy than it can use. Alright, let's move on to batteries. Now one needs to understand that batteries are consumables as well as renewables. Yes, so a battery is a device that produces electric energy from chemical reactions. So, David Udosen, just take us through the charging process of the battery before I introduce yourself.
Hey, thanks, Dennis. My name is David Udosen, like I said, and I studied electrical engineering, and I've been in the energy industry for quite a while. Okay, so first you must understand that for charging a battery, so charging means to apply voltage across the battery terminal, and we have the discharge cycle of the battery really, and the charging process is actually a reverse reaction of the discharge cycle of the battery. Alright, so to specifics, we have three stages of charging the battery. The first is bulk, and the next is absorption stage, and finally we have the flow. For the bulk, you have current and voltage rushing into the battery, and this continues till the battery gets to a preset voltage. Really, we call it the maximum charging voltage. After this, the current reduces drastically and keeps going down till it gets to almost zero. This stage is called the absorption phase. Yeah. And finally, we have the float stage, where we just have little current, little voltage on the battery terminal.
Yes, exactly. Thank you so much. Now, determining the state of charge by measuring voltage, how best can it be most accurate?
Alright, so measuring battery voltages must be done when the battery is not connected to any load and it's not also charging. So you have to disconnect the batteries from whatever sources it is. And not just disconnecting, you have to leave it for some time. So it depends on your capacity. So if you have a lower capacity, like an 8 amp hour battery, you could leave it for about say 30 minutes. Bigger capacities like 200 amp hour battery will take will need some hours for it to settle. Okay, and after that, you simply connect your whatever device, multimeters, across the terminals and take your reading.
Yeah, so your time frame has to be given before you measure the voltage.
Exactly.
Well, thank you so much, David. Alright, so moving over to battery banks. So one needs to understand that if larger energy storage is required, batteries can actually be interconnected together. Now, if one needs larger capacities as well as larger voltages, what would you advise the system build-up solution should look like? Say, for instance, one requires 24 volts and 1000 amp. Yes, amp hour energy storage system.
Okay, so what you have to understand is the regular solutions we have in the market is that the 12 volts, 200 amp hour may not be the best of choices. And the reason is because it has a smaller amperage rating, and that will mean you take so much battery. So we'll give an illustration of what you just said. Yeah, so we have 24 volts, 1000 amp hour. Yeah. So with the regular philosophy we have two batteries in series, and these are connected. And to get the amperage rating, you need about 5 batteries. So you have 2 times 5, 10 batteries in all. But that's not all. These are batteries. Each battery contains about 6 cells. So you have 6 times 10. So you have 60 cells in all.
That's 12 volts containing 6 cells.
Yes, 12 volts containing 6 cells. So you have 60 cells in all. So well, on the flip side of things, if you have a cell, now we have the OPZS, OPZV, they come in different amperage ratings. So you could have a cell that is 2 volts, but is 1,000 amps like it does.
Yeah,
So
sure.
and what does that mean? What that means is just you have
12 batteries.
12 batteries
Connected
stringed,
series, yeah.
connected in series, and you have just 12. That makes just 12 cells, right?
Yeah.
And this is 12 compared with 60 cells. Why is this important? Cells are actually the weak link of battery pack.
Yeah.
So if you get the cells right, the fewer the cells, the better for you. So I think that's the better.
Exactly. Yeah. To do away with losses.
Yeah.
Well, thank you so much. Now, very, very important. If you've not done the calculation before, please don't try it. Now, connection can be dangerous.
Sure.
If you've not done it before, but if you're good on it, fine. Alright, so very important, battery storage and the maintenance. Now, I want you to understand that you never store a battery in the discharge state. You always keep it in a less temperate environment, and when it's charged, do well to recharge on time to do away with sufficient. So David, can you please take us through the maintenance, the best maintenance you advise for a battery?
Okay, so for the lead acid batteries, you want to ensure you clean the terminals periodically, and this helps prevent short circuiting and also to some leakage current, some leakage rather on the terminal. So this helps to make it work. Now for the flooded batteries, you need to monitor the gauge for the electrolyte level. So if you see that the electrolyte is below the preset gauge rate, you add some distilled water. Make sure it's distilled water, and you know where to get distilled water. So I think those are some maintenance techniques you could use for a battery.
Wow, thank you so much, David. Really appreciate it. I tried this video as being insightful, as I promised. And stay tuned for the next video. Many thanks to Engineer Matthew, Ruby Tech, and also Udosen for the fun day. Alright, catch you in the next video.
See you.
Yeah.